Good morning, students. Today, let us see algorithmic thinking in Unit 1 of problem solving using C++. I am Dr. A.K. Jaithunbi, Associate Professor from the Department of Computer Science and Engineering, RMD Engineering College. What is an algorithm? Right? As you all know, it is a step-by-step process. So, it is a sequence of clearly defined steps that describe a process to follow a finite set of unambiguous instruction with clear start and end points. So you should be very clear that an algorithm should have finite set. An algorithm cannot have an infinite set. Okay, and then the instruction should not repeat. There should not be any redundancy. There should not be any ambiguity. There should not be any repetition. So the instruction should be unambiguous. And another important point is it should have very clear start and end points. And an algorithm should begin and it should end. Now, the major properties of an algorithm is so each and every step should be individual. That is, they should do some task, collection of individual steps. Then, definiteness, right? So, it should do certain task, right? For example, getting input, processing, and displaying the output. Next is sequential, right? An algorithm will be executed in order only. It will not be out of order execution. So everything is sequential. And moreover, when you write an algorithm, will define the state, right? So which is the current configuration of all the information kept track of by a program at any one instant of time. So the another important property is detour. Next, the three major important concept in our algorithm execution is iteration, selection, and conditions, right? So iteration, so you have loops, right? Once if you know that n number of times a program is going to get executed, you know how many times this process is going to get executed, we'll go for loop. If you don't know in prior that how many times it is going to execute and based on the condition only it will enter the loop, then we'll go for while loop, right? In certain case you want the set of statement within the loop to get executed at least once, we'll go for do while loop. Then we have selection, right? So in selection and condition, so there will be relation operator and it will return the boolean value true or false, right? So whether the condition is satisfied or not, right? So if it is satisfied, true will be returned. If it is not satisfied, false will be returned. True means 1, false means 0, right? Accordingly it will enter the loop, right? So actually this algorithm word came from al-Khwarizmi, Muhammad ibn Musa al-Khwarizmi, or just al-Khwarizmi, who was a Persian polymath from Khwarazm who produced vastly influential works in mathematics, astronomy, and geography, right? So because of that only the word algorithm came. Around 820 CE, he was appointed as an astronomer and head of the library of the House of Wisdom in Baghdad. Right. So algorithm is very important to solve any problem. So first when a problem statement is given, you are supposed to write an algorithm, right? So what are the mistakes that is possible, or what are the faulty assumptions and what are the gotchas that we'll do is the need for clarity and meticulousness, incorrect use of logical operators, right? So when you are using relational operators and logical operators, we know on what condition we'll be having relation operator, but the logical operators are and, or, and not. So when you will use it, right? So whether both the conditions should get satisfied, right? So you'll be using the logical operator. Then missing certain eventualities and complex conditionals. Suppose you have arithmetic operator, you have logical operator, you have some other operator like bitwise operator, right? In that case the order of precedence, even if you use arithmetic operator also, the order of precedence is very very important. Okay, so these are the important concepts that is very essential in controlling the algorithm execution. right? So finally, the summary of algorithmic thinking is the logic and systematic reasoning are key underpinnings of computation thinking, because computer programs are essentially an automation of our reasoning processes. Therefore, writing solutions requires a good understanding of logic and the ability to use proper notation over natural language.